We previously took a look at solving quadratic linear systems graphically. So we graphed quadratic equation and a line on the same set of axes, and we looked for the points of intersection. What we're actually going to do today is we're going to solve them algebraically. So we're going to do the math that's involved in order to figure out the points of intersection. So when it comes to solving algebraically, the only method that we can use is substitution. So remember, linear systems, we had the option of graphing, substitution, or elimination. We cannot use elimination in this case because we are dealing with quadratic equations. We can't get rid of one of the letters. So that's why we're going to be using substitution. Now, in order to use substitution, both equations have to be in the y equals form, and we substitute the linear equation part into the quadratic equation. So we only have the x value involved. So now we want to get the quadratic equation in standard form, which again is 0 equals ax squared plus bx plus c, or the other way, it could be ax squared plus bx plus c equals 0. It's the same thing, doesn't really matter, personal preference. And what we want to do is we want to use some sort of factoring in order to figure out what x is. So how many answers should we get? We should get 0, 1, or 2 possible answers. Most likely we're going to end up with 2. And what we end up getting, actually, because we end up with a x squared, we're actually going to end up with 2 different x values. So what we're going to do is substitute those 2 different x values into one of the equations and solve for y. Now, the linear equation is going to be the easier of the 2 to solve for. So what does this look like? So again, step 1 is to make sure that both are in y equals form. So here we have y equals x squared minus x plus 2 and y equals 2x. We're good in that respect. Now, what it means by substitution, because 2 things are equal, I can substitute whatever it's equal to into the other equation. So because y equals 2x, I can take 2x and replace the y in the quadratic equation with 2x. So we end up with 2x equals x squared minus x plus 2. Now what I'm going to do is I'm going to get this equation equal to 0. So I'm going to subtract 2x. So they cancel out. So we end up with 0 equals x squared minus 3x plus 2. So because we have a trinomial and our leading coefficient is 1, I can try to factor this up into 2 binomials multiplying by each other. So what that means is to factor, I end up with 2 sets of parentheses. And the first guy will multiply to x squared. So it's going to be x times x. X times x gives me x squared. Now the numbers I come up with have to multiply to be positive 2 and add to 3. Well, the only numbers that multiply to 2 are 2 times 1. So 2 times 1 gives me 2, and now I need to make sure that I get negative 3 when I add them together. So again, when I multiply, so again, 2 is made up of 2 times 1. And the only way I can get a positive 2 is if I did a positive 2 times a positive 1 or a negative 2 times a negative 1. So which one of these 2 combinations is going to give me negative 3? Well, 2 plus 1 gives me positive 3. Negative 2 and negative 1 would give me negative 3. So it's x minus 2 times x minus 1. What I'm going to do now is I'm going to split these up and set them equal to 0. So we have x minus 2 equals 0, and x minus 1 gives me 0. We're going to add 2 to both sides. So we get x equals 2, and add 1 for the other equation to get x equals 1. So these are the 2 x values of the solution, or rather solutions, to this particular problem. What I have to do though is I have to plug each x value into one of the 2 equations in order to figure out the y. and always go with the easier of the two. In this case, the linear equation is the easier one. So we know y equals 2x. So if x is 2, so y equals 2 times 2. So y equals 4. So this means my solution for this particular one is when x equals 2, y is 4. But I also have the other value of x of 1. So again, we still use the linear equation y equals 2x, only this time we have 2 times 1, which gives me 2. So this means my other point of intersection is x value of 1, y value of 2. So these are the two solutions to our system of equations here. And again, we can plug it into the calculator just to make sure. So if we go to y equals, we can plug in our equation y equals x squared minus x plus 2. And the other one is y equals 2x. And if I look at the table, I can see that when x is 2, y is 4 for both of them. And when x is 1, y is 2 for both equations. So that's another way to check. Now what happens when we don't have the proper format? In this case, we have y equals negative x squared plus 4x minus 3 and x plus y equals 1. Again, both equations have to be y equals, so the top equation or quadratic equation is good. But the bottom equation is not. So we have to move the x on over. So we're going to subtract x. So we end up with y equals 1 minus x. So now we have our two equations. We can always rewrite them. So we have y equals negative x squared plus 4x minus 3. And y equals 1 minus x. So again, substitution, we now know that y equals 1 minus x. So I can replace the y in the quadratic equation with 1 minus x. So we have 1 minus x equals negative x squared plus 4x minus 3. Now, what we want to do here is we want to make sure that the x squared is positive because that's going to make our life a little bit easier. So with x squared being negative, I want to add the negative x squared, or rather add x squared. And because I'm moving this side over, this entire side has to be moved over. So I'm going to add x squared, I'm going to subtract 4x, and I'm going to add 3. So I'm going to do the same thing. I'm going to line everything up. So I'm going to add x squared. I'm going to subtract 4x, and I add 3. So everything on this side is going to cancel out. So I'm left with 0. On this side, we have x squared. 1 plus 3 gives me 4. And negative x minus 4x gives me minus 5x. What I'm going to do is I'm just going to rearrange it so it's in order. So I'm going to swap the 4 and the minus 5x. So x squared minus 5x plus 4 gives me 0. So now we're in the standard form. Ax squared plus bx plus c gives me 0. And now what I can do is I can try to factor this out. So if we know we have x squared, so we have x squared minus 5x plus 4 equals 0. As long as I can factor it, hopefully we can. Leading term is a 1x squared. So we can split this up into two binomials, possibly. The only way I can get x squared is by doing x times x. And then what I want to do is I want to list factors of 4. So 4 times 1 or 2 times 2. Now, which of these two combinations, when I add them, is going to give me 5? Well, 4 plus 1 gives me 5. 2 plus 2 only gives me 4. So the numbers we're going to be using are 4 and 1. And again, just like before, the only way I can get positive 4, when I multiply, is a positive times positive or negative times negative. I want my answer to be a negative 5, so that means we're going to be subtracting 4 and 1. So what I'm going to do is I'm going to split them up and set each of them equal to 0. So x minus 4 equals 0 and x minus 1 equals 0. On this side, we're going to add 4 to both sides. So we get x equals 4. And on the other side, we're going to add 1. So we get x equals 1. So this means I'm going to have two answers. One is going to have an x value of 4. The other is going to be an x value of 1. So what I want to do is I want to use my linear equation that we came up with, y equals 1 minus x. In this case, x is 4. So 1 minus 4 gives me negative 3. So this means when x is 4, y is negative 3. So there's one answer. And I'm going to do the same thing when x equals 1. So y equals 1 minus x. Well, 1 minus 1, 0. So this means when x is 1, y gives me 0. So those are my two solutions to this particular problem. Now this last problem, again, we want to make sure that we are in the correct format, y equals for both of them. So in this case, I see x minus y equals 2 is not the correct format. So what I'm going to do is I'm actually going to add y because we want it to be positive. So we end up with x equals 2 plus y. And again, I want y by itself, so I have to subtract 2. So we end up with x minus 2 gives me y. So now that we're in the correct format, again, we can swap them. We can use, we have y equals x squared minus 7x plus 13. And then here we have y equals x minus 2. So now that I know that y equals x minus 2, I can swap it in. So we have x minus 2 equals x squared minus 7x plus 13. X squared is positive, so we're going to leave it. On this side, we have to subtract x and add 2. Line them up nicely. So we end up with 0 equals x squared minus 8x plus 15. So there's the trinomial that we have to try and factor. So we have, so here is 0 equals x squared minus 8x plus 15. If we can factor it out, we end up with 2 sets of parentheses. The only way I can get x squared is x times x. And I want to list off factors of 15. So 15 times 1 or 5 times 3. Which of these combinations is going to give me 8? Well, 15 and 1 make 16. 5 and 3 would make 8. So 5 and 3 it is. And just like before, last is positive, middle is negative, so that means minus and minus. So split these up and set them equal to 0. And we're going to solve for x. So on this side, we add 5. And we get x equals 5. And on this side, we add 3. And we get x equals 3. So now that I know the two x values, I'm going to plug them into the linear equation to figure out the y values. So we know y is equal to x minus 2. So on one case, we have y equals 5 minus 2, which gives me 3. In the other case, it's 3 minus 2, which gives me 1. So the 2 points, when x is 5, I get an answer of 3. And when x is 3, I get an answer of 1. So those are the 2 points of intersection of this quadratic linear system. So again, substitute means both have to be y equals format. We plug in the linear equation part in for y, and we want to get our equation equal to 0. And we can try and factor it Once we are able to factor it, we solve for our x values, and we're going to plug them into the linear equation to figure out our y value. So when x is 5, y gave me 3. That means 5, 3 is a point of intersection. Same with 3, 1.